Hey guys, hi, this is Chiranjevi Sujay and welcome to my channel. How are you all? Today we will discuss about differential calculus, means the chapter called calculus. In that we will discuss today about differential calculus. It is also called as differentiation. We have integration also. Integration. Here, so what is meant by differentiation? No, what is meant by differentiation? Now we are learning about the unit called calculus, and in this we are learning about differentiation. So what is differentiation? The differentiation is a dependence of one physical quantity to another physical quantity. Means how the physical quantity is depending upon another physical quantity. So this dependence of this nature, that nature we can see in the differentiation, and we can tell another words also, like the slope of a graph is also called as differentiation, and the ratio of change in uh, physical quantities also we can call as differentiation, and the amount of variation in physical quantities, that also we can call as differentiation. And the next point is correlation of PQ depends upon them. Means correlation. If we take one physical quantity and if we take another physical quantity, what is the correlation between them? We can learn that correlation in this differentiation. This differentiation was brought by our famous physicist. He is called as Sir Isaac Newton. See, this topic differentiation has more important in this physics subject, and we will learn about it. And we'll get you know the real importance of differentiation, like with an example. So, we take an example of we take an example of a plant, and this plant this plant will take as two quantities, that is height and months. Means we are going to check the how much height it is growing up in a number of months. Means if we take 1 month, how much height it is growing, that we are checking in this example. So we are taking a graph, and here I am making a table. So first, this is an y-axis, this is an x-axis. In this, in the y-axis, we take it as height. In the x-axis, we take it as months or days. We take months also, we can take days also. So here I am preparing a table called as uh, plant height, growth in plant. Growth in plant. Here, here we'll take as height. We'll take height. And here we'll take as months. Okay, this is a table I am taking to, I am taking a data from this, and I will explain this example. Here height, suppose we take in height of 100 meters, 100 meters. Then here we take as 1 month, 1 month. Then after here I will take 120 meters in 2 months. Here I will take 130 meters and this is 3 months. And here I will take 250 meters and this I will keep as 1 year. Okay, this is a table form I have written. This is the data and this is a graph I will draw. Means here it will not be accurate, but uh, I am explaining the term of differentiation, how it is important in physics. So I will take this 100 meters and the scale is 50 centimeters. Means scale I will write as, okay, here we took a graph and we are plotting that data in this graph. So in y-axis I took height, in the x-axis I took months. Here we are seeing the growth of plant. Growth of plant, okay? Growth of plant in height and months. Here I am taking this y-axis as 1 unit is equal to 50 meters. Here I drawn the graph. Now we will plot this data into the graph. Now you observe carefully this 100 meters. This 100 meters is I am drawing like this. Okay. Then in 1 month, the plant is growing in 1 month. That is how much height it is growing is 100 meters. It is growing. Then in 2 months, it is growing 120 meters. 120 meters. This is a 120 meters. Then in 3 months, it is growing as 130 meters. This is a 3 months and we are drawing 130 meters. 130 meters. And in 4 years, 5 years, it is go on. And we will take this an example. See, like this, it is there. So it is here. Do you observe anything? Here we are observing that the plant is growing in a month of 100 meters. It is grown 100 meters. Then after in second month, it is growing 120 meters. Means it more 20 meters height. And then after in third month, it is grown 10 meters height. 10 meters height, it is grown out. Then here we will consider that I am saying that you find out what is the height it is growing in 15 days. 15 days. So 15 days is here, means half of the month. We took as 1 centimeter as 1 unit as 1 month. 1 unit as 1 month. And I am assuming that if that plant grown in 15 days is in 15 days it is a 50 meters. So this is the line. This is the graph. So we can draw this 15 days 50 meters also, but I will ask that you tell me in 1 day how much height it is grown up. The plant, how much height it is grown up. This is the question. Can anybody say? No, because this small interval of time we can't explain because it is so small time interval. It is so small interval of time. So we can't explain it. Here, the physics fails here. So in the physics, they'll ask that what is the shortest time interval that the car is going. Means they will ask short interval of time, which means we can uh, we can we should find the height of the plant in 1 second also. Like that questions they will ask in physics. So we can't able to do that. So that's why we will take as how to find this 1 second of height of a plant. We'll take the topic which has discovered by our Isaac Newton sir, and then the topic is called as differentiation. Okay, understood now? So how much this topic is important in physics, now you all understand. So now, okay guys, now we know how much importance this differentiation topic is necessary in physics subject. And in this differentiation topic, we learn about so many things like formulas, etc. And here we consider this expression, that is y equal to y equal to y equal to f of x. Can anybody say what is this? What is this? Means I will say this is a expression of, this is also called as function. This is also called as function. Here we see the two variables, that is y and x. Okay, this how it will be pronounced? Y is equals to f of x, or y is equals to function of x. We have to pronounce like this. So this y, we draw a graph. This is the y-axis and this is the x-axis. So this y is there, no? This y in the graph, it is known as y-axis. In the graph, it is known as y-axis, and this x, it is known as x-axis. Means y is depending upon the x. Y is depending upon the x. Okay, understood now? Means here any value is there, it is depending on this value. Okay, I will come across to that in few seconds. Here we know that y is depending upon the x. So like this, we have so many types of equations that we have to learn in this chapter. Like they will give like questions. They will give like questions that are y equal to log of x. Here log is came, means it is called as logarithmic function. This all are called as functions. Logarithmic functions. And we have y is equals to e to the power of x. Y is equals to e to the power of x. What is this? This is called as exponential function. Exponential function. Okay, next we have this function. What is that? Y is equals to sine of x, sine of x, or y is equals to cos of x, or y is equal to tan of x. These functions are called as trigonometric functions. Trigonometric functions. Trigo functions. Okay. This function is called as normal function. This function is called as log function. This y is equals to e to the power of x is called as exponential function. And y is equals to sin x, cos x, tan x is called as trigonometric function. Okay. Next, one more function it is there, that is called as y is equals to x to the power of 2. Okay. What is this? This is called as algebraic function. Algebraic function. Okay. This is called as algebraic function. Means algebra means there are two variables and has a degree. So this type of function it is called as algebraic function. Means algebra means it contains variables. Y is a variable and x is a variable. And this variable is in the depending upon y is depending upon the square of x. Means uh, square function it is. Algebraic square function it is called. Okay. Now we will talk about the I said from on starting that differentiation is called as slope of the graph. Slope of the graph means slope is how to find a slope. You know, in maths we have studied how to find a slope. This is a graph. This is x graph. This is a y-axis graph, and and we have some data in it, and that data is like this. Okay. Then we have attached this point, and like this it is came. And if we draw a straight line, means if we draw a straight line connecting these two dots, connecting these two dots, and the line which is drawn, it is called a straight line, and it is drawn in an inclination. Means it is drawn in a some type of slope. That slope it is called as theta. This slope of the line it is called as theta. We know that, how that slope is found with a trigonometric ratio, that is tan theta. Tan theta. In maths we have studied this. And here uh, I said about differentiation is also called as slope of the graph, and this is the graph I took, and I drawn a straight line, and I know the slope. I found out the slope, that is called as tan theta. And here we are saying that in differentiation we are going to know the slope of x-axis and y-axis. Means we have two data in this, and we have joined like this. Here I got a triangle. Okay, here I got a triangle, and this is a theta. here we will know the how much slope it is, how much degrees it is having the slope, we can know it. So here this is a theta, and opposite of this is the opposite side of theta, and this is the adjacent side of theta. And here O by A is in trigonometry, in the maths chapter, we know as it is called as tan theta. Tan theta. So the slope is also called as tan theta. Means here we are finding the slope. This is a straight line, and here I join the lines, and I see a triangle in it, and I find the theta here. This is a theta, means from x-axis it is going like this, and here it is forming the theta, means angle, and this is called as, and here the slope is called as tan theta, and this is called as O by A. O by A. Okay. Here in differentiation, I said that differentiation is needed in small immeasurable quantities. You know that? Immeasurable quantities. See, one more it is there. If you write delta, delta is change in that particular variable. We, in the terms of this graph, I will write as changing y axis by changing x axis, delta x by delta y, delta y by delta x, and this delta represents the change. This delta, it represents the change, and it is also called as measurable quantity, measurable change, measurable change. Means this word, this symbol delta is used in measurable quantities. Like, we take as a distance time graph. Okay, this is a distance, this is a time taken, this is distance, and we have some graph like this. You think this is the graph. Here we took, this is an y-axis, this is an x-axis. So here they will give somewhat distance, that is example 10 kilometers. 10 kilometers is the distance, and time they will give as 1 hour. 1 hour means 60 minutes. 60 minutes. So here I took the distance part and time part, and I have plotted this graph, and they gave certain interval, means certain time, that I can measure it. But if they gave in 1 hour, in 1 second, how much the object it is traveling, means how much distance it is covering, they will ask, means I can't find out. Or they will ask like this also, in how much time interval, sorry, in 0.1 seconds or 0.001 second the object is traveling, how much they will ask that how much distance it is covered. in this time interval. So we can't assume that, and we can't calculate it. So this type of quantities, this type of measurement, we call as immeasurable quantities. Immeasurable quantities, and we can calculate these immeasurable quantities in this differentiation. We learn about the differentiation means we can calculate this immeasurable quantities, and this is called as immeasurable quantities, and it is denoted with dy by dx. Understood? Why we will write dy by dx and delta y by delta x. Delta, it will be represented as measurable changes, and dy by dx we will write as immeasurable changes. Immeasurable changes. So here, so here, for the differentiation, we always will write as dy by dx. We always write as dy by dx. Dy by dx. Here, okay, next. This is important part. This important part, measurable quantity, we will represent as delta, and dy by dx is called immeasurable quantity. Okay.